my day. Oh, do you guys see our principal walking around?
No.
Mr. Matt. Will that He looks young. But I'm excited. Hey, not that young, complicated. Alright. Sorry, I'm in record. Let's get started.
What happened to Turtle?
Thank you. Thank you. Come back in 3, 2, 1. Thank you. Let's get this done with, then we can have all these conversations. I can schedule all your test assistants that you need to take today. Thanks for taking your earbuds off, completely off. Oh, I like that.
I like how my computer goes, Zay Munoz, going live now.
Oh, nice. Does it? That's cool. All right, so the last thing that we did was to convert these values into the complex, right?
Yeah.
Going from this to polar form. Okay. Now, next piece. Taking two complex numbers in polar form and multiplying them. Stop. Let me give you the formula right here. Can you guys see that okay?
Yeah.
Let me try to do this real quick. Maybe that'll... Nope, that didn't work. What am I doing? Like tag. Oh, that's a little bit better, yeah? So, if you have two complex numbers that are in polar form and you want to multiply them, notice the differences here. What you're doing is you're going to multiply the two moduli. Is that right?
Yeah.
Yes.
The moduli?
Uh-huh.
And that's going to be the sum of theta 1 and theta 2. And then you'll have, yeah, so the argument will be the sum of the two. Thank you. Someone pay attention to the vocab.
It's right there.
Ah! Touche. Touche.
Pulling my phone away.
I don't get credit.
Wait. What does Z represent again?
Z represents a complex number. In this case, it's in polar form.
What if like people from like Germany or somewhere, like somewhere just out of nowhere, we're watching your videos, it's really popular today? That'd be funny.
Oh, that would be fun. Well, you know, I can
Like on a
see where
billboard
people
over there.
watch them, and there have been from other continents.
They're just like, ooh,
But like, do something like, hey,
something in like
you
a
were
different.
good, you were not good.
Maybe they're gonna hear this and they're gonna start.
Maybe they will, maybe they won't.
Say it louder into the microphone.
I have a YT studio on my phone. I don't use it a lot. It's the YouTube studio. Lets me manage my channel.
Big baller. Kick him out.
Disrespect. You guys have this formula copy down? Lexus, you have this? You're gonna need it. I'm gonna change it now.
No.
Do you have Microsoft Lens? Guys, if you don't have Microsoft Lens, you need to get it. It's free. It lets you take pictures of presentations, and even if you're at an angle, like if you're over there where one of these guys is, it'll fix it so it looks like it's head on.
Oh.
It'll make it look really cool.
I like
It
it.
is, huh? You have it?
Where do you get it on?
No? In your stores, your app stores.
Wait.
You kind of went like, oh, all right, we already have it. Cool.
Did you ask him?
She's like, no, I know. But yeah, it's a pretty cool app. I like it a lot.
Oh, my mom says that so much.
I like it a lot.
Like, where do you guys get that from?
That's from Dumb and Dumber.
Yeah.
I got worms. All right, I can change it now? No. What are we, writing calligraphy? Whipping out all the details and stuff? Come on, man. We're good? Okay, let's do it.
Wait, I need a picture.
What is that?
Wait, it might be on the subject.
I scare myself when I do that. Oh, man, that's me. Darn. Darn. Come on with your 0.5 megapixels. Okay. That was
me.
Here's your next problem. I haven't done, what are those, flip phones? Those are
Yeah.
flip phones?
Feels so tough. This is my birthday.
So Z1 times Z2, what's that going to look like, guys? 6 times 5. And then I've got cosine of...
What?
Cosine theta. 40 plus 20 plus I sine 40 plus 20. So we've got the product is equal to 30 times the cosine at 60 plus I sine at 60. And of course, those should also be in the polar form, right?
Alright, well, can you slow
So what's that going to be? 60 is pi thirds?
Yeah, okay, slow down.
After we got
Slow it down a little bit, because you're moving really fast.
Home, home on the range. Where seldom is heard a discouraging word.
We used to have a horse that played that for Rocky Country.
So you meant like an actual horse?
Yes, I had a horse that like that just shot. I was like, oh, how did you teach it?
You're like,
What's up?
come listen to the podcast.
But I will pay the price line a little bit.
Well, you have
This is not a full lesson. Let me put it up there.
Oh, you see.
It's only like half a lesson. Because we started it on Tuesday.
My dad.
Okay, good.
It's Pi Day.
Okay, we good? No. Okay. That looks weird. I'm gonna write this again. Is that cool?
Yeah.
That is why we are.
Party har har.
What is it called?
Party har har.
Microsoft Lens?
Yes, Microsoft Lens. It's a red icon. It's got like a shutter on it, kind of thing. That there shutter.
It's your shutter.
That there shutter, Cletus. I took that from my kids in 6 hour yesterday. Someone like saying that is like, you can't say Cletus without wanting to do a country accent. Hey Cletus, what you doing out there? All right. Thank you. If you can multiply them, what? What do you mean the little form? You should go through the whole process again, right? That should give you an angle.
No, she's talking about like.
No, that's it. You're done. You've multiplied them. That is it right there. That is the product of the two in polar form.
Wait, that's
That's it. That's the product of the two in polar form.
so you don't, they don't want you to like simplify.
No, that's it.
They don't want you to?
No, you're not going to simplify it. You just want to take. Thank you. You're taking two complex numbers that are in polar form and you're multiplying them. Well, if you multiply two things that are in two real numbers, what should you get out? A real number. Okay? That's like the first theory that you should have talked about. It's called closure. Okay? If you take a real number, you add a real number to it, you're going to get a real number. You don't get peanut butter. Okay? It feels that way sometimes, right? Like, whoa. So, here we're multiplying some complex by some complex. We're going to get out hopefully get a complex as well. Okay? All right, so there's your product of the two.
But are there ever instances where you get a real number out of a complex number?
Yes, if you multiply by its conjugate.
You have to distribute the 30.
But even then, you can still express it as a complex. Go ahead.
You have to distribute the 30.
No, that's just stays outside. Remember, we're looking for. Remember that a polar is going to be in the form of. Oops. Right? This is how we write a polar. A complex number in polar form. It's got the modulus, and then you've got the arguments inside. So that's exactly what we did here. We have a modulus 30, and then we have our arguments. In this case, turned out to be a 60 degree.
You don't need to change it to the
No, we're just looking for the complex number. No, somebody said that, but you don't have to go there.
That would be going to rectangular form, wouldn't it?
Yeah, if you were going to go to rectangular form, then you wouldn't need that.
Oh my God.
Hey, just like you can multiply them, you can also divide them. So if you're looking for, there's your formula. Notice that it is the quotient of the moduli, and then instead of adding, it's going to be the difference of the arguments. And that should make sense, right? Consistently with mathematics, what we've done.
Yeah.
Usually multiplication is some form of addition, division is some form of subtraction. Well, that's exactly what they are. Multiplication is just glorified addition. Division is just glorified subtraction. Or as we call it in elementary, grouping. No? Put them in groups. How many groups do you get? Up top. No, paper's not edible? Oh my man. Trying to get some extra iron in your system?
Wait, I tried it.
Should I clear that ink for you guys?
Wait.
It's pretty cool, huh? Oh, look it. Is it
I
good?
tried to do it, but then like the contrast just goes crazy.
It does go a little weird on some of them because you're kind of. But if it was a board, I think, like whiteboard, it would look much better. Try with the whiteboard. Do what? I can't hear you. Yes, I can take off the ink.
Oh my god, look, it made it look like I'm looking at a whiteboard.
Let me see.
I really don't like
Let me see.
Okay, I took a picture of this from the angle. This is gonna make it look like it's right
Yeah, but it makes it look like you're right there, doesn't it?
Oh, that's
crazy.
Isn't it cool?
That's crazy.
I saw that on your wow.
Guess how it does it?
Oh.
Math.
Oh,
When it has, you know the little frame that gets on there? It knows the dimensions, so it's going to do a ratio. So it knows how much to blow up one side versus the other side. Oh man, that math is everywhere.
Wait, what's it called?
Photo,
Microsoft Lens.
I look like this.
Okay, let's do this. Man. Sure. Let's find the quotient of Z1 to Z2. In this case, we got 50 divided by 5. And we're going to have cosine 4 pi thirds minus pi thirds plus, thank you. Let me put this like this. Plus I sine 4 pi thirds minus pi thirds. Close. So it looks like we have 25. 10. No, I messed up. Sorry. So this should be cosine pi, yeah. Because 4 minus 1 is 3, 3 over 3 is just 1. So we got cosine pi plus I sine pi.
And it's minus inside because it's division.
It's the difference of the two, right? Because
Okay,
it's
and
division.
then when it's multiplication.
It'd be the sum of the two. Simple enough?
Yeah, but and then when you do the plus I, is that a negative in multiplication or no?
Say that again?
So like you see the plus right there?
Oh, it would be multiplied technically.
No, lower.
Yes?
Yeah, so no, right there, yeah. So in multiplication is that
Plus.
Okay.
Still plus.
It's all plus?
Yeah.
Okay.
Still plus.
It's just the inside of the cosines that change, right?
Yeah, the two arguments get added or they get subtracted is division. Okay? We good? I can change the slide?
Yeah, hold on.
Greg, you need a laptop, please? Take these notes. We gotta have a laptop open. You recording me with your low quality camera? Oh, they don't have back cameras, huh? Oh, I thought they did. My bad. Alright. Now, what's up? Still not done? Okay. My bad.
Do you have any plans for spring break this tomorrow?
You know what? I feel I'm getting sick right now, which is I'm upset because I've been sick pretty much every break I've had.
Yeah, that sucks for you.
I
You're
know.
like sick over break and you're
And
not
I
gonna
really
get
think
over
that I'm gonna be getting over it. But you know what I'll probably do? I'm gonna go find me a lake that's full of ice and then take a dip in it.
Actually, why?
Full of ice?
Have you ever taken an ice bath?
No, but that's what I said I want to do.
You guys do that?
Huh?
No, it's code.
Why? Why are you gonna do? Why
Like
would you
using
do
an
that?
ice
It's
bath?
fun.
I have a theory.
You ever taken a long?
Do you know how bacteria can survive within certain temperatures?
You're gonna get.
So if I lower my body temperature low enough, I think they'll kill all
What
my.
if you get sucked under the
You'll
or you
die.
kill
You're getting
yourself?
cold. Or I could die. But I won't be sick.
No
No way.
matter what.
I mean,
It's a win-win.
without even.
Touche.
You won't get
Yeah, but he only needs the good.
Thanks for ruining my plan. With your science.
Hey, she's in biotech, so she would know about it.
It's not even from bio.
No, that's just
Science.
regular science.
Like biology.
Alright, here we go. Olo. Which is thank yous. Thank Julio.
Me again?
Oh, last chance.
What?
That's what it says on here. It says go. You're in trouble. I think.
Who?
I don't know. I'm not gonna read the whole thing. Just go. Okay. Now,
What?
this one says if you're gonna take some complex number to some power, okay? So if you have z to some power, so let's, for example, let's take, what do we have here? R times cosine theta plus I sine theta, okay?
Don't forget the.
What thing?
The end, there's an end at the end.
No, I know, but I want to explain what's going on.
Oh, okay. Well,
I'll get there. So here's our original complex number, correct? If we're going to take it to some exponent, then here's what happens. You're going to go, in this case I'm just showing an example. If it's to the second, then this would become r to the second. Then we would have times cosine 2 theta, correct?
yes.
Plus I sine 2 theta. And then close, okay? So,
Okay.
switch your 2 for n. If you're wondering why that works, multiply it out. And you will see that it does produce that for you, okay? Anybody want to see that get multiplied out? That'd be good
Yeah.
time.
Kind of. Yeah, I want to see it.
Okay.
Don't go anywhere
Yeah.
yet.
Don't go nowhere.
That thing above that's a 2, right?
I put a 2 there. It should be n. Technically, it should be n. So this should be n. This should be n.
But you're doing it.
This
as
should
an
be
example,
N.
so-
That should be n. Okay?
Up there next to the. That's the Z2 monsters.
Okay, you better not.
Z squared.
In the yellow?
Remember that. Twilight.
This is the. Look at
That's
this.
one. Oh, that's one. That's whole. Oh, that's a Z.
You know what I'll do? I'll come back to this if anybody wants to see it. Because I want to do one more thing that's a little bit more.
Okay.
Okay.
I know racing.
But all I'm really saying is if you really want to see how this formula comes about, where this is squared and then I put the numbers there, all you have to do is actually go ahead and square this out, and you'll see that you're going to get those values out there once you've simplified everything. And we can all thank Mr. Good old Demois for this. Demois, or Demoivre. I don't know how to say his name. Demois. Demois. What?
Down bus. Bus down.
Are you insulting me?
Are you?
Are you using your pig Latin on me?
My brother knows how to speak it so fast. I'm like, when do you get time to do this?
Can't do it. Okay. Are we good? All right, here we go then. This is the last thing you need to know. Commentate.
Namaste. Namaste.
This is good old Demois. Yes, this not nice Demois. Okay. This is writing these.
Oh my god.
So
Sorry.
they're having you find all the nth roots. Okay? You guys remember when you were graphing parabolas? You would get what is this? This is 2 real roots, right?
Yeah.
And then we had a situation where you had 1 real solution, but then you had a situation where your parabola was totally above line, right?
Yes.
And that would have no real solutions, but it had 2 imaginaries. Okay? Now technically this had 2 reals, but it happened twice, so the answer would be the same 2 times. Here it was 2 very different ones. Here they're both imaginary. So what we're trying to find with the Moab's rule here is going to be all those roots for this. This is the formula. Go ahead and copy that down. I'll explain to you a little bit. I have a chat with my boss here. Hello, Shepherd Pie.
He's a little shepherd pie. Bring him up.
That's right. Would you like more coffee or what?
Sorry,
Yeah, like a coffee, a tea, like that energy drink, like, yeah. You know what's getting closer? Yeah, no, well, start up. Dragon's Slayer weapon. No, you can yeah, something, yeah, get a weapon. Get the Dragon Slayer weapon. Did you? I didn't get the chance to go because he's busy though. Just answer it.
Mr. Moody, student speaking. Animal in trouble. You gotta save. Dude, I wanna watch that.
Wait, can you get in trouble for letting your students?
Oh, this is a student, so you want me to send a message to Mr. Munoz? No, it's a student.
It's like the 3rd time we said it.
No, he's talking to Mr. Anderson. Yeah. He like call back like in a couple minutes. He call back in a couple minutes and Munoz is done talking. No, he's talking outside with Mr. Anderson.
I know who's that. What the hell? It's like the sun.
Hey, what's happening? What's happening?
Yeah, for minutes.
No, the lady's stupid.
Yeah.
She wants to talk to Mr. Munoz, but he's outside.
Just say that.
That's what he kept telling her that. I'm like, student speaking, hey, Mr. Munoz. I'm like, student, you're not Munoz? No.
Somebody just.
Oh, Munoz, yeah, you just had someone call you and they were.
Oh, it's time for lunch.
Something with test.
Is it?
No.
Hold on. All right, so
Lunch isn't for another like.
okay, so let's talk about what's up. I don't know. That's your guys' thing.
Please.
Okay. So you guys got this formula down?
No, I don't. Can I ask you a question?
Yes, please do.
Is this the square root of b?
This is the nth root of. Well, no, you're trying to find all of the nth roots. Okay, and this is the method you're going to go about it. Now, there's 2 things that you need to know. For starters, k, because k is going to get swapped out in this position. So if you're finding all the second roots, then k will become 0 and 1, because it's 2 roots, correct?
Yeah.
Second roots.
I don't even know how. Just keep going. I'll figure it out.
Okay, they're going to ask you to find nth roots. Nth meaning they're going to give you the number of roots you're looking for.
Oh,
Okay? So they'll say, hey, find all the second roots. That means that you're going to get 2 roots. So you will start with 0. And then you'll go to 1. That will literally spit out the two roots that you want.
Keep losing my name.
Okay?
So would you just plug that in?
Yeah,
for
you just
A?
plug in all the necessary information. If they say, hey, we're looking for all the fourth roots,
So 0, 1, 2.
then you'd go 0, 1, 2, 3, that's 4 roots. This is why it goes all the way to n minus 1. So technically, if I'm looking fourth roots, I would start with 0 and go to 3.
So you have to, so if you're looking for the fourth root, you have to do the equation 4 times.
Yes. One for each one of those. One where k is 0, one where k is 1, one where k is 2, and one where k is 3.
So we would just plug that into the calculator like that?
No, you would have to do it by hand. I see what you're trying to do there. That was good.
Dang it.
Now, the only reason why we've seen two of these formulas up there is because one's in radians and the other one's in degrees. It's not a big deal. It looks just like what we've been doing. Okay? We have our modulus up front, and we've got our two arguments. And we're just trying to find all the different roots of that. Okay? So don't think it's some crazy monster that it's because
Are
it's
you
not.
gonna do an example of it?
We can. Would you like to?
Yeah.
Okay, so if I could go to the next slide. So here we go. Find all the complex fourth roots of 16 cosine 60 plus I sine 60. Write the roots in polar form. So, okay, not too bad, right? Let me grab my formula here real quick. Okay. So let's start with the first one where I've got c sub 0. Cool? I'm supposed to take the root of 16, correct? Which root of 16?
4.
The fourth root. So what's the fourth root of 16? 2. So this becomes a 2. Then I'm going to have, what's the formula read? Cosine?
Cosine.
What's in here?
Theta.
Theta, which is 60.
It's
Times or plus?
Plus.
Plus
2
2 pi k?
Yeah.
2 pi k. K is 0, correct?
Yes.
So 0, that means this all goes away. And I'm dividing it by how much?
4.
4, because n, my nth root is 4. N is 4. And then I'm going to do it over here again, which is plus I sine 60 over 4. So my first one, once I clean it up, z sub 0 is 2 cosine 15. 15 degrees plus I sine 15 degrees. And there's the first one.
Wait,
Go ahead.
how did you get n? N is fourth roots. The n is how many roots you want. Got it.
And k is going to be n minus 1. So that means I've got 0, then I should do 1.
So should k be 3?
Wait, why'd you scribble that?
That's the maximum. But where do I start with? I have to start with
Oh, so you have to do
k
all
being
of them?
0. And that's that same idea of going coterminal, right? If I'm here, that should be where k of 0, I've got no rotations on there. But then I can rotate one more time. Pop. That's where k is 1 rotation. Then I've got 2 rotations, and then I've got 3 rotations.
So how do you know which one to do? It just depends on
How do I know which one to do what? What do you mean?
Plug in for k.
Okay, so let me answer that because that's a good question. Go away.
I got it all here.
We'll do it again. We'll do it again. For starters, what's my n?
4.
It's 4, correct? That means that my k's that I use are going to be 0, 1, 2, and 3. Because that gives me 4 roots. Even though I have to start with 0, 1, 2, and 3. So, n will always be 4. Except when I do the formula, I'll have to do a 0 where it's 0. I'll have to do one where it's 1 for k, a 2 for k, and then I'll do one where 3 is k. So I'm just repeating that formula 4 different times.
So whenever you get this kind of problem, you have to do all 4 of them.
Yeah, because how many roots are we looking for? 4, because it's the fourth roots. Okay? Questions on this? Go ahead. Then n is 5, and you're doing it 5 times, where k is 0, 1, 2, 3, and 4. Say that one more time. No, you wouldn't, because you're always going to go. The number of times that you go, I'm trying to get to that slide, is going to be n minus 1 times. So you can start with 0, technically. Okay? Wow, you're doing that 9. Yeah, you're doing it 10 times, where k is 0 all the way up to 9. No, because what are you going to do? right? All you're doing really is simplifying this what's the word I want to use? This mold, if you will. I'm simplifying it. That's where those complex roots are going to be at. Distinct complex roots. What's the point of a complex root? Well, when they're complex, for starters, they're going to be on that imaginary axis to begin with. So in the real realm, it probably won't be very realistic. You gotta wait a little bit.
I love that song.
Munoz here.
Said you offered it.
Do me a favor, have because I have to leave for meetings right now. But Mr. Razzo can unlock. Mr. Razzo, he's gonna be at 3609. Okay, and then we'll have him do that, and then also Ms. Duncan. I don't know what her extension is. Okay, so she can also do some unlocking, so that way you don't feel like you're overwhelming either one of them. All right, Mr. Razzo. What's up?